All right, hello and welcome to another classic arcade game clone game dev session. Today I'm gonna attempt to clone Pac-Man. We'll see how far it goes, and as usual with these clones, I'm not trying to make the pixel perfect original arcade version. I'm just trying to make something that is very similar and get as close as I can within a limited time. So usually, I don't know, maybe maximum of 5 hours or something like that. We'll see how long I can run here, but yeah. So let's get into it. So to start, I have this kind of template set up for this. It's a zig project, and we're going to be using raylib for library, for rendering, playing sounds and stuff like that. And I'm also using an ECS library for creating entities and using components and systems and all that. And then I was thinking for this project, I'm also going to add like a state machine system. Hello, Polaris. Have a nice day yourself. Thank you. All right. So yeah, let's get started here. I think actually first thing I'm going to do is gonna just get a Pac-Man sprite sheets in here. So let me bring up that Pac-Man arcade sprite sheets. Thank you. Oh, we got a couple of things. All assets and palettes, attract mode and HUD assets, general sprites, maze parts, text. Okay, let's look at this one. This seems to have like everything. The maze and everything. It's like also in a nice grid format, and it seems to have maybe the maze and stuff as well. Yeah. Okay. I guess we'll take this one. Not sure why you would need what all these things are. Maybe it's like different versions or something. Where's the yellow Pac-Man? Huh. I guess, I don't know. Let's, well, maybe it's further down. I can't scroll down for some reason. Okay, let's download this one. All right. And I'm going to copy that over. What was it called? No? Oh, it ended up somewhere else. There we go. Okay, let's call this the sprite sheet. All right, so now we have the sprite sheet. Hello, Penguin. Hello, Polaris. All right, so we have the sprite sheet, and the first thing we probably could do is load that sprite sheet in. So we'll enable loading in our sprite sheet here. And let's see, I'm gonna look up, since this is more like asteroids, that the last game we did was asteroids, and then the kind of resolution of the screen didn't really matter too much, just that it kind of looked, because we're using like vector graphics and stuff, it's like, yeah, kind of more forgiving. But this game is like, it has actual, you know, maze parts and stuff. So if you render the maze at a certain aspect ratio, that like makes a difference. So I'm gonna look up what the actual resolution is for like classic Pac-Man arcade resolution. And according to AI, it's okay. I'm gonna assume width is not higher, right? It's in this like a vertical game. 288 vertical. Yeah, 224, 288. Okay. All right, let's do the little trick we usually do here. Are you going to bring all the games together in one lobby? Sorry, I haven't been watching in a while. So all of the classic arcade game on YouTube, they are available in a playlist called like Classic Arcade Clones or something like that. I don't remember what the exact name was now, but I don't have that many playlists, so hang on. It's called Classic Game Clones. So yeah, so all of the game devs all of the live streams are available in that playlist, and then each one has a link to the corresponding repo link in the description, including this video here. So it's not uploaded yet. I mean, I haven't made the game yet, so I did put in the template, but yeah, I have to make the game and then I'll push it at the end of the stream, so the repo will be updated then. Are you gonna bring all these together in one game? Oh, you're saying that. Well, then I would probably, I would have to finish the games, I guess, first. Like right now, it's more like how I'm gonna see like how far can I make a game in one stream, essentially. I don't plan to like make completed versions of the games because some of them require like a bunch of, you know, they have different levels and there's a bunch of nuances that I just don't have the time to get into. So it's more like getting the core gameplay in. I feel like. So probably not. I'm probably not gonna do that. So yeah, if you've been following along or otherwise, you know, I can tell you that I've never actually fully cloned a game. It's more like how far can I get in one stream to make one game, and I usually, you know, try to make the core gameplay work there. I think the one that I have made the furthest was probably Asteroids. That one I probably, like, there was a few missing features like colliding asteroids colliding each other, and the one that I made the least progress was probably Defender, because that one had like a bunch of nuances when it comes to the coordinate system wrapping around. But I did all of the basic things. I just had to like spawn a bunch of aliens. I didn't do the AI of the aliens and stuff. So there was a ton of missing things on Defender. Maybe I'll actually come back to that one, because that was actually a really fun one to do, because it was so different. And Asteroids was really fun as well, because I made a ton of progress on that one in a short time. But now let's focus on Pac-Man here. Yeah, I might come back and like finish off the core gameplay loop of them, but I won't like do all the levels of everything, because there's a lot of work there. We might do like a stream where I try to go back and finish off like the core gameplay of some of these games here, and then maybe, you know, do something with that. I don't know. But anyway, let's start here. So we have our little sprite sheet. We have a player. What game are we doing? We're doing Pac-Man, right? So the Pac-Man has a level, right? I mean, first of all, let's get our Pac-Man in here. So I'm gonna open up dear old GIMP. Here's some Defender stuff. And I'm gonna open up the Pac-Man file. Man, I don't even know all these palettes because the ghosts are like, there's 4 ghosts, right? And then this palette, which is when they are... I mean, do I want to make like a system for the palettes? Or is this like different palettes depending on which level you're in? I don't even know. The Pac-Man is obviously green. Sorry. Let's take that again. The Pac-Man is obviously yellow. But then these colors doesn't make sense to me here. So this is weird, actually. This is kind of weird. Wait, this is the yellow Pac-Man. What is this one then? And this, but this is red. Okay. I mean, this color makes sense. Or this. I'm not sure, actually. Because the outlines are different. Man. This is confusing. Okay, Pac-Man complete sprite sheet with all palettes ripped and sorted by... Okay. I mean, I guess we can just pick and choose what we want to have. So I was thinking like maybe we should make like a system where each palette is corresponding to a number. And then you can select the palette. You basically have one sheet that is like repeated over and over. And then you select, so basically the graphics will be like, okay, first select your palette. And then your source rectangle will be, you know, one thing in here. I mean, yeah, and we could maybe try to do a full mapping of like a coordinate, like a grid coordinate. So this sprite will be like 0, 0. This would be 1, 1, or I mean 0, 1. No, 1, 0, 2, 0, 3, 0, and so on. The problem is down here we have a different one. But I guess we could have like one for 8 by 8. I guess this is 8 by 8, right? Makes sense. 8 by 8, yeah. And these are 16 by 16, maybe. Yeah. And then, yeah, that's it. Like we have one that is for 8 by 8 and one that is for 16 by 16. We could make a system like that. Or we could just say, hey, this, I'm gonna choose like a good yellow color here. I guess, is this different? This looks a little bit more greenish yellow. This looks promising. Actually, this one here, yeah. So the bottom one is the Pac-Man color in these 4 palettes things here. So I guess we'll pick this one because that's the only one that has yellow. So we could also do it like this, like, yeah, this is just, you know, select the source rectangle. This is the actual sprite. Yeah, let's just do that. So we'll have like this. I'm gonna choose. We need a couple of different ones here, I guess, because it's like an animation here. And then I'm not sure where these ones are used for. Is it when you die or something? I know this is the death animation here. And I'm not sure when this is used. But okay, let's pick this one. So 303 by 709. 303, 709. Okay, so we'll init a sprite. And you need a rectangle. 303, 709, 16 by 16. And we have a tint as well. No, we don't. We have a source rectangle. That's all we have. Okay. We could add a tint. Wait, in its right. Oh, texture, right. We need a texture. All right, there we go. Cool. Let's start this up. And we have our template here is, you know, ready to go. I can move around. Okay, I need to make sure that you can actually see the actual game later as well. Still compiling. So first time compiling takes a little while because we're compiling like raylib and everything. But now that should be good. Okay, we can see it already. So here's our little pac-man. We can move around. We see the coordinates up in the top left. Okay, so cool. We got our pac-man in. Now let's set the screen size. So this one was 224 by 288. Was that correct? Yes. Okay. So let's see how that looks. See, resolution should be, the aspect ratio should change here. Yeah, that looks good. I actually need to, either I can zoom out or I need to resize this window a little bit. So there you go. Now you can see everything. Okay, so there's our little pac-man. Cool. Okay, so I guess, you know, the maze, I'm just gonna do like one type of maze, I guess. I'm just gonna make a file called maze, and it's just gonna be the maze. We'll make a bunch of parts probably. So we have like a bunch of different walls. Let's look at the sprite sheet here. It's not going to be these ones though. It's going to be like one of the top ones here. Actually, if we look at a screenshot, how does that look? Oh, it's like dark. It looks like this. It's like dark. It's just outlines. All right. So it's not these ones. So it's like these ones here. Is that the only one that has like outlines? Okay. So we got a couple of different parts here. Not exactly sure which one is which. I mean, where are these used? Not sure. But I guess we'll take each part and make it into one thing. We could also maybe do this to make it a little bit easier. We can select this area, make this into like a mini grid. Because it has, you know, it has like even spacing, and we can then just select a coordinate from those, so we don't have to do every one in, like, okay, well, this is 745 by 187. So I'm gonna say we have like a sheet grid. It's gonna be rectangle in it. And what was it now? It was like 745,187. That's the position. And then the size is 53 by 62. Okay. Cool. So that is our sheet grid. And then we can have a function that gives us the source rect of a coordinate, a grid coordinate. So we'll get grid coordinate is a vector, and that gives us the source rectangle. And so first we want, so the grid coordinate corresponds to where in the grid this thing will be. So here's 0, 0, here's 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, and this is 0, 1, 1, 1, 2, 1, 3, 1, and so forth. So so first we have like x and y, and we need to multiply the grid coordinate by, so this will be the actual sheet coordinate. It's going to be grid coordinate times, or scaled by 16, because it's 16 by 16. No, it's 8 by 8, sorry. 8 by 8 things. Hey, procrastinator, Pac-Man, yes. Okay. However, we also want to add one, because that's the spacing between each one. We have a 1 pixel spacing, so we have to add 1 to that. So now we have 8 plus 1, that is the, so we'll do like spacing is 1, and we'll have cell size is 8. So this is like cell size plus spacing. Okay. So that's our sheet coordinate, and then the rectangle will simply be sheet coordinate x, sheet coordinate y. I'll fix the LSP in a second here. And then this will be the cell size. So there we go. There's our source rectangle for that. Okay, and then we can define every wall now with a grid coordinate, every wall piece with a grid coordinate instead of a actual pixel coordinate in the sprite sheet. All right. So we can say, for example, we can say actually, you know what we'll do? We'll make this, because this really could be comp time. So, and comp time doesn't work with scale here because of Raylib's library doesn't like work like that. So we can actually just say, let's say I'm gonna call this cell factor or something. It's gonna be cell size plus spacing. Okay, there we go. That's the same thing, essentially. All right. And so what we do is we have a bunch of these walls now. So we have like, I'm not sure what this is. This is like top left. Like what do we call this? Like top left, just top left, wall top left, or is this wall? Okay, let's just call this, these pieces are just wall, curved wall maybe, straight walls. Not sure what to call these. Inner walls, oval. I don't know if we even need these here. I'm just gonna map this and these for now, and we'll see if we need the other ones. Because if I look at the screenshot, I don't actually see. I see the inner walls, like the thin walls, Okay, so we got thin walls, thick walls, and then the straight walls, but I don't see the other ones. So I'm just gonna skip those. These I'm gonna skip. And then we take, actually, let's do curved, or these are gonna be just walls. These are the straight walls. Actually, this is like the prison walls. So let's call it the prison walls. And then these are the inner or thin walls. Aren't like other walls reused for interface segments? Probably, maybe. I mean, if we look at the screenshot here, you can see here is like the thick walls or the normal walls. Here are the straight or prison walls. And here's the thin walls. You can see they're thin there. So yeah, I'm only gonna use those. All right. So we got like this 9x9 is gonna be the normal walls. So we have like top left, top right, and so on. The center is like just empty. I'm probably gonna skip that one. Top left, top right, and so on. Okay. Top left. So wall top left is, so this is a grid coordinate. Actually, we could do just, we call source and init 0, 0. Wall top is 1, 0. Wall top right. I'm always contemplating to just say top left like this. I don't know. 2, 0. Then we have left is gonna be 0, 1. And we skip the middle one because that's just a black square. Right is, no wait, 0, that's 2, 1, there we go. And then we have bottom left is 0, 2. Bottom is 1, 2, and bottom right. Okay, so those are the normal walls. Hello, hello. Why do you need thick walls? Because there's thin walls and thick walls here. I believe these walls are the thick walls. Like this is probably like one, this part here is one cell. And then this part is one cell. So this would be the top left thick wall. And this would be the top right thick wall. And these are thick walls here. These are thin walls, the ones on the outer here. Because you can see they are thinner. And they are their own like cells. They contain like one cell contains one of these, I think. I don't know. We'll see. But we definitely need the thick walls. The thin walls, I'm not sure, but we'll need the thick walls at least. And the straight walls here, the prison walls in the center. They are straight. What's the use of the source function? Okay, so the idea here is that if we look at the sprite, whoops, the sprite. So the sprite, if you look at this section here, you have a bunch of wall segments, right? They are stored in these 8x8. Each one of these is 8x8, and then they're evenly spaced out. So we can calculate if, let's say we want this one, right? We can just say that, okay, this is an 8x8 square with position 0, 0, right? Let's say we start it, and then this is like grid position 1, 0, because it's the next one over. So this is grid position 0, grid position 1, 0. Now to get the pixel coordinates, which is down here, 754,187, we have to take this grid coordinate 1, 0, and first we have to move over 9 pixels here, because we have 8 pixels from here, and then 1 pixel in the spacing here. So this one is 9 pixels over. So it's the cell size or the cell width plus spacing. And then we also add this position down here to get the actual like pixel rectangle of this grid cell. Okay, so that way we can calculate basically any of these cells from a grid coordinate instead. So it's like making it easier for me to define these things. So I don't have to look up every cell, pixel coordinate of every cell. I can just think in my system coordinates and just say, well, this is the top left one, this is the one over, this is the next one, and so on. So it's easier to define these walls, essentially. And what the source is doing is taking this grid coordinate and calculating the final pixel rectangle that we need. So we're essentially just, we're creating a rectangle here. This is the position. This is the size. The cell size is 8, so it's an 8 by 8 rectangle. And it's the X and Y, it's the top left. It starts at, so we take the grid coordinate and we scale it by cell size plus spacing. So 9, this will be 9 here. So we basically just times it by 9. And that will give us the correct coordinate in the grid. Actually, I forgot one thing actually. It's good that you asked this, because I did realize that we also need to add X and Y of the sheet grid here, because otherwise we will pick from the top left of the sheet and not from this offset over here. Okay, cool. So, but we don't really need this coordinates here. We could simply just have this actually as a, this is actually more like an offset. So grid offset. And we don't actually need the size here, but that's fine. Okay, so we have these walls. Now, let's see if it works. So we can go, let's go into draw function. And I'm just gonna draw them straight up somewhere here. Just make some temporary code here. We'll import, no, we'll import maze. You can import anywhere you want, essentially. And then the maze will say, well, then we have all these source rectangles. So we could say, for example, well, we can make, let's say we make a renderable, a sprite, and the texture is gonna be do we have texture here? No, we don't. So let's get singleton and we'll get texture. Okay, so that's our sprite sheet. And we can just pass that in here. And we have the source is gonna be maze, bottom left. Let's do top left. Let's try and make this wall here. Okay, so top left and top. I mean, probably just wanna, let's just do these 3. Okay, so top left, we're gonna draw at, I don't know, let's make a cursor. at like 128, or let's do like 64. Actually, let's do like 128.64. And that is our position, and then rotation is 0. Okay. And then cursor we add to X, we add 8, because that is the size of these. Top draw and top right. Okay, so now we should see this wall now being drawn. Just testing that this works here. There we go. Here's a little wall here. Okay, that's how it looks. Now, the thing is then how we actually define this wall. So this does work here now. Okay, we could probably make some sort of like grid where like we divide the entire screen in like 8 by 8 cells, and each cell, it's essentially tiles. So each cell will be one specific tile. Okay. We could also put these in like an array, perhaps. You know what? We'll just make the maze is going to be well, this can be comp time as well, so we can just make this a public const thing. But essentially, it's going to be, we could make just a slice of, yeah. Let's do it like this. So we'll have, this is the maze. We're just gonna have one layout. Let's call it the layout, actually. Or maybe, no, let's call it maze. Maze layout. Maze layout, yeah, sure. This will be a slice of constant rectangles. So so that's what that's gonna be. And I'm gonna equal that to comp time break. So in here, there's only comp time code, and we have to make a layout here. I'm pretty sure now I can shadow this. And this is a const rectangle thing. Okay, so this will be a little bit weird because it's like comp time, but essentially, and then to get this value returned to get maze layout's gonna be initialized with this value, we can break this out like this. So this is a way to kind of, you can use a block of code and a label to create a value. It's essentially, you can do this if you don't want to have to, you could do this yeah, without creating a function. I mean, we could also create a function that does this thing as well. I'm gonna watch your streams after my exams are over. Okay, gotta go now. Okay, well, yeah, prioritize your school first, please. Put them in a dictionary or array the walls. Yeah, I'm gonna do something like that. Thank you. So yeah, but let's just make it like this, okay? I'm not gonna fuss too much about the method that I'm using. Remember, I'm practicing production speed here. Okay, and now is the question, like, okay, so let's say we want to add a bunch of well, also we need the width of the maze. So maze width is going to be it's like, well, we don't need to type it though, I don't think, because we're not gonna change it. It's going to be like, well, I don't know, actually. It's going to be like the pixel size over 8 or something like that. So the pixel size of X is like 224/8. That should be, so what is that? 28. Okay, so let's do 28 width. And then the, yeah, so actually, and then we also need height, actually, which is 288/8, 36. Okay. So then we could I mean, we could just start by looping through maze width and maze height and set maze layout. Whoops, this is y. The index is x plus y times the width. And set this to, wait, no. We don't actually need the index. The thing is here, this is going to, because, yeah, I'm just gonna try this out first and then we'll figure it out. So this will be, I'm just gonna set everything to be I'm gonna make a tile. This tile is this. The rectangle is not in it. It's gonna be wall top left. So let's fill everything with a bunch of wall top lefts. I'm just gonna make, like, try to make this work here. Okay, sure. It's already comp time. You are shadowing. Okay, fine. Let's call this the result then. These are not used. Okay, I'm gonna try and make a multi, also, yeah, we could make a kind of map of the maze as well, like a string. I'm gonna try and make that as well, but I'll just try this to see if this actual thing works now here. I'm not sure why we don't get this. Imported correctly. Wait. Oh, I removed the things. Okay. So now we have this maze layout. We can loop through it. We also need the index. So this is the source or the tile or whatever we want to call it. Let's call it source or tile or source or tile or source or tile. And this is I. Okay. So we'll loop through it and then we'll make the sprite is game renderable in sprite. Texture is texture. Get singleton. Why is nothing working here? No. Do we have texture here? No. We have render texture 2D. Is it because of this? Alright, so we have the sprite. And then we draw the sprite. And then the position will be source source X, source Y, scaled by maze cell size. All right, and then we draw this at position with 0 rotation. Oh, there we go. And I is not used. No. This is not wrong. This is wrong, I mean. It's not the source X, source Y. It's gonna be X and Y is gonna be defined by I. So X is I modulus maze width, and Y is I over, it's actually div floor I maze width. That is X and Y. And when we scale it by the cell size, yes. Oh. And we have a bunch of things here. So what you do when you get this error, evaluation exceeded 1,000 backwards branches, that is essentially if you're trying to do something in comp time, but you have way too many iterations happening. So the comp time basically gives up after a while to not get stuck in infinite loop. So what we're gonna do is you can say set eval branch quota, and I'm just gonna pick a number here. Let's do like 10,000, for example. That should be good enough, probably, hopefully. Okay, there we go. Now we got through that. It might impact performance of like compilers stuff, but you know, if you're doing too much stuff in comp time, but it's just a one-time work thing. So this is happening in comp time. It doesn't happen in runtime, which is a really good thing for runtime speed. Okay, but anyway, you need to be this, and you are a U size. So let me then say F32 int from, no, float from int, and float from int. All right. Okay, let's see if this works. We should be seeing a bunch of top left walls everywhere. Okay, cool. So we have a way of defining like all the tiles. This is essentially our sprite sheet right now. Or I mean the tile sheet, and so, or yeah, we have a tile sheet and we have a tile map essentially. So we can kind of draw the maze here now. But now we need a way to actually define what should the maze be. It shouldn't be a bunch of these, but we could use this. Well, no, let's actually do a thing here. I'm gonna make a maze layout string. And this is a string. We don't really need to define it being a string. This is a multi-line string. If you have two backslashes, it's gonna be a multi-line string. And so, and then you can, you know, have a bunch of these. So we're gonna have, I'm gonna do a layout which is like, it's going to be 36 of these. So I'm gonna copy this, type or delete 36. All right, so we have 36 height, and then 28 of those. So I'm gonna add that. Is that 20, 28? I guess so. We'll figure it out. Okay. So then I'm going to add that in. Oops. I'm just gonna do, actually, we'll do this. So that. Okay. There we go. A little macro saves the day. Okay, so we have this layout now. And then I want to map, I want to create like a map from a character to one of these tiles. So let's make a map. So map of, well, we could just make a function actually. Map map character to tile, and the character is a U8, and then we get a tile back, which is a rectangle. And we can basically just switch on the character. Okay, return, and essentially you could do this. If it's a dot, we will return, well, it's gonna be empty actually. So let's actually do this. Empty, tile empty is number 2. Wait, no, it's 1 1. So this one will correspond to tile empty. Okay, so now we should get a bunch of empties if we map this here. And then I will say, like, you have to have an exhaustive switch. So I'm gonna put else. This is actually gonna be a compile error, because this should be like a com time actually jar here. So if we get here, that means we have a compile error, and we're gonna say invalid tile char, and we can actually put this in here, except you're a char, so let's just make a string. Okay, does that actually work? I don't know yet, because we haven't actually mapped it. So what we can do is we loop through the maze, and we get the index. Also, what you have to think about here is, like, because it's a multi-line string, every line here has a new line at the end. So we have to make that, take that into account here. So, but the index, so let's do it like this. Index starts at 0. It's a U size. We are going to loop through 0 to this is the index of the string. So maze layout string index. Okay. And then we're gonna loop through maze width times maze height. And this is the maze index. Okay. Or should we just loop through? Maybe we should just loop through the string. Okay, let's do it like this. We have x, it starts at 0. We have y, so this will be kind of like our cursor here. And then we'll just go through the string. Okay, this is the character that we get. This should be a U8 here. And so then we switch on the character. No, we check if character is a new line. What we do is we say y plus equals to 1, continue. Okay, so we skip the new line by increasing y by 1, and then we continue. Also, x should be reset back to 0. Okay, but otherwise, we continue down here, and then we'll say, so the tile should be map char to tile char. Okay. this is going to give us a rectangle. I'm not sure why it says unknown here, because we're clearly given a rectangle here. Okay, there we go. Now it works. It was the LSP. I had to reload the file. Okay, so we have the rectangle. So now we can just say result is equal to result plus the tile. Okay. Except I need to actually make you the type of constant thing before, so that zig actually gets happy here. There we go. I just changed the type. That made it work. So and also x plus equals to 1. Okay, so we don't actually need x and y, I just realized. We just add to this thing here. Yeah. Okay, so let's actually, we don't actually need this. We just skip the new lines. Yeah. Okay. And that should be it. And as you can see, if I try to run this, we should just get a bunch. It should just be empty now. If everything works. Okay. That works. Also, I'm not seeing pac-man, so this should happen before. Actually, let's call this draw maze. Actually. Draw maze. There we go. So pac-man is drawn on top of the maze. Okay, there we go. We have pac-man, we have the maze, but the maze is like empty right now. It's just a bunch of dots. Okay, but now let's try. I'm gonna put in some garbage here and showcase. You actually get a compiler error here, or not. Well, we do get a compiler error, but it was not the one I was expecting. So same thing here, error char whatever is a string. Okay, now we should get a proper, invalid tile chart D. And we can even get, well, we don't have the position to show, but we could have gotten that if we passed it in here, but as metadata. But invalid tile chart D. So if we put mistakenly something in here that we don't have support for, we're gonna get compiler. So not really production speed now, but now we have a way to define this maze more easily, because I just hate manual work. I don't know. I just like to automate things. So this way, at least we can do that a little bit more. So let's look at the screenshot that we have for pac-man. And so we start down at some ways down, and then we have some, we don't fill the entire screen. And I'm not sure if there's borders. There seem to be some space to the left and right, maybe. I'm not even sure if this is the proper correct maze that you actually have in the game, but let's just assume it is. So, I mean, we could maybe try to count these, but I'm going to just, I wonder if this is the top left wall. It looks different. Okay, let's compare to the sprite sheet here. Maybe it's not this one. So it's not this kind of oval one, right? It's gonna be this, right? Yeah. So let's define these walls here. Actually, I'm not sure what to call these walls. I mean, they are the thin walls. Let's just call like thin top left, top right. We can make these top left, top right, bottom left, bottom right. So we have thin wall, top left is going to be, so this one is like 0, 1, 2, 3y 0. X is 0, yes. Can I please get the correct window? There we go. 0, 3. That is top left. Then we have top right. Goes over by 1, 2, 3. So it's 3 by 3, or yeah. And then bottom left is 0, 1, 2, 3. Right, so it's just adding 3, so it's 0, 6. And then bottom right is then 3, 6. Okay. Now I want to be able to map to these, so we'll pick some kind of now we have to pick like a character to represent the things. So I guess we could pick, there are these kind of weird ASCII symbols that you can use maybe for some of the things actually. So there's like, well, ASCII table. Okay, this is just 128. I want like 256. No, this is 128. Where's the extended? I guess extended. Okay. Wait. Okay, these are the extra ones then. Okay. So you can see here, here's kind of these wall things that you can use. So maybe double is going to be thin walls and single is going to be thick walls. That makes less sense, I guess. But so we have like, it's a shame I can't copy them. Okay, let's do AI mode here. Yeah, thank you. But where's the extended? This is the extender, sorry. This looks bad though. This does not look great. What the hell? Okay. Can you show me the ones that look like walls in a monospace font? Solid wall, shaded wall. Yeah, these ones here. Yeah. So let's, I mean, this one, for example, we take top right corner, right? This will correspond to wall top right. Okay. So if it's just an ASCII, so it's not like UTF-8 or whatever. So if you put this over here, whoops. No, replace. How can I? Okay, well, put this over here. This might be more. Wait. No, that's one character. Wait, it's a U8. Oh. Oh, this is not UTF-8. So this is UTF-8. Okay. What if we copy? So which one was that? That was 191 decimal. 191. Let's copy this one and see how that looks in here. No. Okay. I thought I could use this. Why do you not work now? What the hell is going on here? Okay, let's just use let's just use letters, whatever. So this will be bottom left, right? So I'm just gonna try to add a bunch of these. Why not just 191 wall? Well, the problem is that I wanted to also kind of look like a maze in the string. So I wanted to, you know, and there you can see we can kind of map from the string here. So I wanted to make to, like, you know, at least somehow look like it. So, but zig source code doesn't support like UTF-8. So, and that specific, I guess, you know, font, this font shows a different, like, I think it's like the older fonts showed like walls for those characters, while newer fonts show something else, the upside down question mark there or something like that. Like actual, more like, you know, I don't know, maybe it's the encoding. No, I actually don't know. But anyway, so that's L. Do we have like a what's a good J? Is maybe bottom right or lowercase j? No. Let's do that. We'll have this is gonna be wall top, and this bottom, and then whoops, we'll have like this could be left and this could be right. Okay, let's try this. So essentially we have some bottom, we have right, and then top. How does that look? It kinda looks okay. Okay. Except this needs to be like, you know, bottom right. You can also place this in a file and load it in, but now it's like it's compiled, so it's kind of part of the thing. What if we put like top right here? We don't have top right. Top right is kind of like, we could pick maybe T or maybe this, but then that's like an escaped thing, so that's not great either. We could do this maybe, top right, top left. This one, looks kind of shitty in here, but at least it's gonna be easier to define. What is happening? You can't handle these? Let's do top left this, and then top right. I don't know, this. Okay. So there we go. We have a little thing here. I mean, we could try to. The thing about Pac-Man is that I forgot to change, like add alpha to the sprite sheet. I'll do that soon. Is that essentially you're kind of locked to the corridors, but yeah, we'll figure that out. Also, there's like pathfinding and stuff like that. I'm just gonna try and make this maze here. So we can do something like, well, I can do this actually. And then we'll bring in this thing. Let's put you down here. Okay. Can I like expand this somehow? What does this mean? Let's open this image. I'll just mess up my layout here a little bit. Okay. We need for the thin walls as well, though. So that's gonna be cool. So the thin walls, we have like top left. I'm gonna say top left. Top left is slash for the large one. Maybe a plus? No. I'm just gonna pick something. I'm just gonna pick a plus here. That's the thin top left. Okay. I'm also gonna pick this for thin vertical. I'm pretty sure this is one thing. If you look at the sprite, you have like a vertical. It's not actually vertical. It's also aligned to one side. How do they do that though? Oh, is it this one? No, it's this one. So it's like the prison right is actually gonna be fitting. Okay, yeah. I need the prison as well, the prison ones. So this is actually gonna be vertical and then left. And then I'm going to pick lowercase l for vertical right. Okay, let's start there. And then we also need thin horizontal. Down or top and bottom. The top is gonna be, I don't know, let's pick like the bottom like that. Okay. Yeah, we need to define these as well. So thin wall vertical. Well, I'm gonna do like the prison walls. Prison top left is this one, so it's like 0, so it's 3 0. No, 3 0. And then prison top is 3 1. No, it's 4 0. Prison top right is 5 0. And then we basically have, I'm gonna do the bottom, or top is bottom, and you're gonna be 2 times down. Okay. And then we have the middle part. So this is prison left and prison right. So prison, that's gonna be 3 1. Prison left. And 5 1. Prison right. So that's gonna be what these are gonna be here. So we got like thin wall, vertical left. Yeah, so it's going to be aligned to the left. This will be prison left, I think. And then thin wall, vertical right. It's going to be prison right. And then we have thin wall, horizontal top. It's going to be prison top. And bottom is bottom. All right. Cool. We don't really need to map those though. Okay, let's just try this here. What I'm gonna do is I'm gonna open up a different buffer. Move to the map so we can see which one we should use. Probably gonna do these ones down here. Okay. And so yeah, I'm just gonna, can you expand a V into a Q? Yes, you can. Cool. Okay, so we go down. So first it's like, I don't know, 1, 2, 3, 4, 5 something rows down, or 5 or 6 down. And then we can just shift it later if that's the wrong thing. So this one is the thin wall top left. That's a plus. And then the next one should be like, I think, prison bottoms. Or thin wall horizontal bottom. So a bunch of these. Not sure how many. We'll do like to the end. And then at the end, there's, you know, top right, I think. Or bottom, no, yeah, top right. Thin wall top right, which we don't have. So that one, I don't know. Tilde. I'm not sure, you know, how effective this method is. I should probably just, you know, have downloaded a data table. But there you go. Here we have the beginning of this maze. Okay. We have in the center somewhere. How much is this? 26. Is this the center here? This looks like the center. 13, 12. It's actually 2 in the center, these two. So which one would this be? I wonder if, yeah, it's probably these two then, maybe, or because this is 1. This whole thing here is 1. So it could be like, but the bottom of this tile is, no, it's actually here. Right? Am I crazy? No, it is there. Oh, because we're using the top, right? We're using this one. Yeah. Except this is the bottom, yeah. It's placed at the top. The wall is placed at the top, but it's actually called bottom. So the ones in the middle should be these ones. Okay, here we go. Here's the center ones. So let's just call these the center tiles, like center top left, center top right. I don't know what to name them. Okay, so this was like 0, 1, 2, 3. So it's like 1. So 1. No. 3 by. No, 1 by 3. Yeah, 1 by 3. Thin. So let's call this like thin wall center top left. This one is source 3, 1, I think I said. And then center top right is 3, 4, 1. And then we have to make symbols for these. So let's do like, I don't know, comma, and X. And you then are comma and X. That's not right. Thin wall top center 0, 1, 2, 3, 1. 3 by 1, 3 by 2. No, 3 by 1, 4 by 1. Yeah. Why does that not work? I don't have duplicates. And that is what you map to. Don't forget to save. Huh. Actually, let's just do this. Why are you like this? Wait, did I define this correctly? Source. Oh wait, this is the other way around. God damn it. It's 3 by 1. No. Yes. 2 by 3. Oh my god. I'm not sure what my brain did there. Okay. This is gonna go fast. Yeah, I probably should. So what I should have done is probably download a table, because this is probably laid out even in like the source code of like the class. Like you could probably get like the source code of the original Pac-Man, look up the table definition, just copy that over, modify the make it so it work in your programming language, and have it work there. So I'm doing like a maybe very inefficient way of doing it here, even though the way I probably wanted to do it was more well, anyway, let's just continue here. We're stuck with this method here. Vertical left, I'm pretty sure we should use the right one here, or is it the left one? It should be, no, it's the left one. No, it's the right, because this no, these should be the other way around, actually, I think. And this should actually be right, and this is left. Yeah. Which means that we should use left, which is this one. So you're going down, I don't know how many, 1, 2, 3, 4, 5, 6, 7, 8 of those. Okay. And then we go down here. Is these, or has to be too wide, because the Pac-Man is like 16 by 16, so the wall has to be here, I think. And the wall top left is that one. So here's the beginning of that wall. And then we have like 1, 2 of these. No, not that one. Wall top is dash. And then the end is top right. It's this. And then we have wall right. Wait, let's do this row first. I think this is then, it might actually be just 1 here. We can just remove that if that's the case. Yeah, because now we're already at the center here. So I think this is just 1. But this doesn't make sense. Do we have like extra space somewhere? You are 12 and you are also 12. Because this goes down. But now we don't have enough space here. So I am confused. Have you done any... hello, Blue. Have you done any shader stuff with Raylib? Not yet. That would be a future stream, probably. I mean, definitely. Okay, well... Yeah, I feel like we're missing some. Okay, let's just see how this looks here. I'm gonna make these come down as well. This should be the right wall, and this is the left wall, maybe? Or is it the other way around? We'll see. We have left and right is these ones. So we have like 1, 2, 3, maybe. And then this is bottom left, which is L. And this is top left, which is that one, right? Yeah. It could be that these are only one space long, because it feels wrong though, because this feels like this should be 2 spaces wide. But I guess we'll see how this looks. Okay, maybe this is too wide. So this was actually correct. It's just 1 wide, and this should be 1 more. Yeah, okay. So actually it's like this. These are only 1. But then you are longer there. Okay, there we go. But this is wrong. What the hell? Top left. Oh, it's bottom right. Actually. Okay. We're making it piece by piece. Next wave here. That's another one of these. And another one of these. It goes faster once you know kind of the layout here. And then we have the other wall, which is, I think it was lowercase l. Okay. Hello, robotic head. What's up? Okay. Did I get... No, not somewhere. Did you raid or something? Oh, thank you. 5 people. Thank you very much. Yeah, no problem. Welcome, welcome. Let's see. Okay, so now we have the next one, which I'm not sure if this is like 1 wall as well. Down, probably. So that's gonna be like this, I think. And then here is gonna be... I should probably make the bottom wall... I don't know, it doesn't actually matter. And then L and J. Look at this beautiful ASCII art here. Yeah, because this comes down and ends at the same place there. So now we should have those top boxes there. Another kind of issue that we're gonna have to deal with here is gonna be the collision detection and stuff like that. But we could just map. We could make a spatial hash thing or not. Okay, I'm gonna stop using hash then, because that's a different algorithm that I had in mind. But essentially, we could just make a spatial grid where each each cell is like solid or not solid, and then the pac-man could, you know, navigate through that. We'll see how we can make this here. Okay, so the next one, this should be just a copy here, except it doesn't have, it's gonna be thinner. And then you are just gonna be this and then this. And then you go down, continue down. Like 1, 2. And not sure, is this a bottom left here again? Or top left? I guess. And you're top right. And then that goes out. And then we have basically a copy like that. And okay, let's see how this looks. No, okay, that is not a top right, it's a bottom left, maybe. Wait, no, it's a top, it's a bottom left. Yeah, okay, it's a bottom left like this. Okay, but now we can also take this, copy it over here, and this goes over you, and then you go 2 more, and then you are, I guess, top right, you're top left, bottom, bottom, bottom right, top right, you go down 1, do you go down 1 or 2? Yeah, 2, and then LJ. Okay, that should be that middle part. Can't you see the maze clearly in your mind when you look at the ASCII there? You are then this and this, this and this, this and this. And then over here is going to be you and you. And then top, top. And then this L, top, top. This J. Okay. Hello, cool guy. What's up? How's it going? There we go. Pac-Man is in the way a little bit. All right, we're getting there. We're getting there. Okay, I guess we have another thin box over here. So let's just copy that, put that over here. Okay. See, we even have a copy paste functionality in this editor here. Okay, so this is going to be this one, which is a thin something something wall. Not exactly sure which one. Let's pick oh, we don't even have like bottom left, bottom right. We need those as well. And those will need new symbols here, so I'm just gonna pick, I don't know, let's pick a lowercase. No, this one is a lowercase j, and you're actually better off being a lowercase l then, but I'm just gonna pick like, I don't know, Q? No. How is it? It's like, okay, I'm gonna pick C for that one. So you're gonna be lowercase j, right? Makes sense. And then we have the, I'm gonna guess this is the vertical or the horizontal bottom. It could be the top, actually. Horizontal top. No, it's bottom. No, it's top. It's bottom. It's top. Top. It's V. Yeah. Because the other one is over here. So this one is V. Okay, let's see if that's correct. You can't see it? It's like the matrix. Okay. Looks good. Then we have, I believe it should be this one, plus. And then it should be 1, 2, maybe even 3 of these. Yes. And then we have bottom left, which I think I made a C. And then these should be the other ones. Those ones. And the last one here is interesting. It's just going to be another one of these. I could have made it also like, okay, that's not correct. That was not correct. Do we have more of these? Yeah, hang on. This is different from this as well, a little bit. Wait, so which one would we need to use then? One that goes like this, but further down. Is it this one? Okay, so I'm gonna try this one. It's like 1, 2, 3, 4, 5 down, 2 over. So 2 by 5. That is thin wall. It's like a top left, except it's further down. So I'm just gonna call this thin wall top left 2. What did I say? 2 by 5. And then we're gonna need the other one as well, I believe. Well, let's try this one first. Thin wall top left 2. So plus. I'm gonna do star. Okay, let's see if that is correct. Please start making GTA 1. Wait, why did that? Did I forget? Oh, 2. There we go. You have a list of games to make, or just randomly choose from the internet? Yeah, I basically randomly choose. I don't have like a pre-list of things. Huh, that's almost correct. So that was actually wrong. That is interesting. So which tile is it? So it's gonna be like this or like this, except it's either, oh, it's just this one. It's just top left, the normal wall. Oh, so that is just this one here, and then you're gonna be L. Okay, but yeah, these are wrong now. So that's gonna be okay. Interesting. So is this is just these, I think. But then we're missing the inner wall. Where are you getting those assets? Man, just search classic pac-man sprite sheet, and you will find it. I promise you. Okay, let's do... Yeah, that's true, Cold Guy. That's awesome. I guess we'll try these. No, that's too thick. This is gonna be too thick. Okay, I'll have a look at the sprite sheet again to see. Yeah, too thick. Kind of got a weird visual there effect. It could be... So it's not going to be another one of these. It's like this, except I guess it's like on the left only. Wait, or we switch it out with this one. Okay, why no? Yeah. Whoops. Also, I'm probably gonna allow spaces for the maze as well. So I'll fix that there. So let's do not... Is it gonna be else then? Probably. Yeah, that makes sense. That makes sense. There we go. Cool. Okay, and also we can see that we have the correct grid, like we have the correct resolution and everything, because we placed the grid exactly as the thing here, and it fits perfectly here. So we have the exact correct, you know, width of the maze. So that's good. Cool. So let's do the other side. So we have that corresponds to this. We can move this down a little bit. Okay. Lower J was bottom left. So let's do bottom. No. Yes. Wait. No, that's bottom right. Okay, bottom left. Yeah, C. And you are gonna be V. Same thing. And then this one is that, I think. And then you're gonna be these. So it's like we're gonna be the other way around. You're gonna be J, and you're gonna be a bunch of these. I think that's correct. Yeah, cool. All right, let's do it like this. Let's do space. I'm gonna allow space to also be tile empty. Can do this as well. So now what we can do is we can replace these with spaces, or I'm gonna do like this. I'm gonna do the maze part is gonna be space. The boxes are empty, maybe, so it's easier to see where the maze is, maybe. I don't know. So these are the empty things around. There we go. Can't you see the similarities now? Okay, so here we have the prison. The prison top left. I don't think we have that mapped. No, we don't. So we need those prison top left, top right, bottom left, bottom right. So we need another one here. So this is, I'm just gonna pick like O is prison top left. Big O top right, K bottom left, D bottom right. Okay. So we have O, O, and a wall, which is going to be, I believe, this wall, and then you're this wall, and then you're gonna be your K and your D, and then these are these guys, and you are these guys, I think. I don't know. We'll see. Except it needs to be one more, I guess. Yeah. So whoops. K. Or maybe even two more. No, just one, I think. Wait. No, maybe two actually. Maps are made like this. Yeah. I could have also programmed a tool where I can use the mouse to draw the map. I don't know. This is also fun. This is another way to do it here. Okay, we've got, this should be the opposite, and then this should be the same, I think. We got, whoops, we got 3 of these. So now it's just, I think it's just mirrored. No, it's not actually mirrored. It's not actually mirrored. But this thing here is mirrored. Mirrored. So you are J, you are these, you are top left, same as this, plus, and then a bunch of basically all the way to the bottom, except maybe 2 or 3 or 4 up or something. We'll figure it out. Right, that's that side. It's gonna be the same on the other side. Let's see if this is correct first. Okay, yeah, that looks correct. Except we have like a thing that goes out here, but we'll fix that in a sec here. Okay, so the thing goes, there's a thing going out here, so it's just gonna be these 1, 2, and 3, I believe. Yeah, there we go. And then we have the same thing over here. Okay. Over here we also have these. No, else you are a L and L. These are these things. You are a, what are you? Okay, I guess I can kind of see the, yeah, this is the same as this. It's a tilde, or whatever that symbol is called. And then a bunch of L's. Okay, there we go. Now we have this part. So this, we have top. We have this, we have J, 2 goes in, L, here is, which one would this be? It's gonna be L and J, I think, no? No, it's gonna be these, I think. And then, whoops. Okay. Then we have like 1, 2, 3. And we have another one of these over here. 4, no, it's 5 by 1, 5 by 2. We have you 2 over this J, except you are a L, no, you're this. Okay. Is this not symmetric? It is symmetric, except the other way. And you are a that. Okay, let's stop here and see where we are. If it's correct. Yeah, that looks good. We could almost like move this up a little bit because it feels like we have a bit ways more to go, and we almost used up our entire thing here. So okay, so this one goes out here. So this one is we haven't used yet. Yeah, it's these weird things. Comma X, but it's not those that we need to use. So we need to use new ones. This is like center top left, center top right. Now we need like different ones. So we need like these ones here. This is like center left top, I guess. Center left bottom. Center left top and center left bottom. There is a method to this madness here. I'm just gonna pick something here. M, that's fine. I basically stopped trying to make this look like an actual maze right now. Center top left, center top right, left top, and left bottom. So top was at 1, 2, 3, 4. So 0 by 4 and 0 by 5. Okay. And you are mapped to top, bottom, yeah. And so over at here, I believe it goes out. So you are top. Yeah, you're one of them anyway. And then these ones are gonna be, yeah, they should be like, that should just be like this. Okay, let's see if that works. Oh yeah, and we need the other side as well. Okay, we got the little thing going out there, cool. Okay, and then the other side actually needs the mirrored version here. So we need these ones. So it's gonna be like center right top, center right bottom, which are at like 1, 2, 3 by the same Y. So so we're gonna copy you switch out left with right. And you're gonna be over, same Y, but over by 3, I said. 0, 1, 2, 3, yes. Okay, and we'll copy you, and we'll just say, I don't know, H. So H, same thing here. Okay, let's just double check here. Thanks for not vibe coding, no problem. That takes the fun out of programming. That was not correct. Oh, did I forget to change the names here? Yeah. There we go. How's the temperature? It's pretty cold for the summer here. It's like maybe 20, not even 20 right now, I think. What about you? How's the temperature over there? Let's see. So, which one is this? This is the thing that comes down. These are these kind of pills over there. Here we have the top of the thing. And we continue over here with another one, which goes all the way there. And you continue with this. And then here's another one. Essentially the same thing here. Okay, and then these go down. You just continue here. And then here we have these, unless it's the other way around. Yeah, it's the other way around, I think. Yeah. And then you go down maybe 2, yeah. And then, yeah, there we go. That makes sense, because now we're at the bottom. There's 1 space left for the wall. Well, yeah, we might move this up some more, but okay. And let's see, and now we can continue with these. You go down, at least down here. And then you are a J, I think. And an L. These are then they should be bottoms there. Oops. Because then, and then you're this. No, then they should be top. No, yeah, they should be top actually. Yeah. And then you're a J. And then we have a bunch of these down, probably down all the way there. L. No, actually here. This and then top. Okay. And then essentially almost exact same thing at the other side here, which goes all the way there. However, these ones we need to move over here. There we go. Let's see if this looks correct. It's nice to see the progress. Yeah, there we go. Okay, we're almost done with the layout here. We just need to do this bottom wall and we're done. So you extend all the way down there. You extend all the way down there. And then we have these ones, which are going to be the corresponding to these, except the other way around. So I guess it's gonna be like J and C. C and J, excuse me. And then a bunch of V's. Okay? It's hot. Okay. How hot? All right, there we go. We have the full layout here. Original layout. You can see a couple of issues here, though. When we move around the Pac-Man, we can move around willy-nilly here. So what I'm thinking is we can, well, first of all, I want to make Pac-Man transparent, so we don't get this black shadow everywhere. Well, that could be an effect. You could say that's like a feature, not a bug. But yeah, let's just bring out a dear old GIMP here, and we'll select by color. I'll select black. Actually, first I also want to add an alpha channel. Actually, there already was an alpha channel. Okay, but let's just remove that. So black was probably just, you know, background, because the black background is black anyway, so it will be like transparent. Okay, and then I will just replace the original with that. Interesting that there was actually transparency, but they didn't use it. Okay, and then we need to copy this over. So now we can get rid of this layout that I made here. I'm just gonna, whoops. No. Okay, there we go. Wait, why are you so weird? Oh, I need to do this. And then this. Okay. Okay, there we go. And then you back to where you were. Something like this. Okay, cool. And I'm gonna also move the browser up there and there. There we go. Back to normal here. Cool, so we got our little maze layout here. I'll probably move this up maybe by 2, perhaps. So that we get this little space at the bottom there as well for things like UI and stuff like that. We'll show maybe even one more, I'm not sure. Because there's like score and stuff up here, and down here is like things as well. There's 3 rows up and 2 down, so it's not even. So I'm gonna guess that it's like actually we could replace all of these with spaces now. Pac-Man's like, what are they? Yeah. It doesn't really understand what they are. Apparently it has the power to phase through them. That's a new ability. Okay, so there we go. There's our maze layout there. Now, what I'm thinking is we could make kind of like a grid layout thing. So let's make a grid thing, which is made to, this is going to be used for collision detection. So we're going to make Pac-Man basically snap to the corridors and everything. Hopefully with this. So I'm just going to make a grid thing here. We're going to have the data, which is some kind of data here with cells. We'll see what that will be. We have width, we have height, and let's make an init function. Let's make an allocator. We'll grab an allocator. Okay, and then we'll take width and height. Oops. give us a grid. So data is going to be allocate cells width times height. This can be an error, so we need to try this here. And then width is width and height is height. Okay. Now let's do like cell equals, let's just make this is solid, is a bool, that's gonna be false or something. We can probably have other information there as well, but I'm just gonna do this for now. Okay. And what we need is we need to be able to check for, I guess we need to be able to check for collisions and resolve collisions. So checking for collisions is just checking if some rectangle is colliding with the grid, and resolving the collision is like pushing the box that collided, because we were just gonna work with axis aligned boundary boxes and not any other types of collision shapes. So it's basically gonna be rectangles that are not rotated. So resolving a collision pushes the box out of the collision, so you're in non-collided area again. So we're gonna need. So what I'm gonna do is actually, this is also interesting because the last time I did a grid-based spatial thing for this, I encountered a bug where you basically get stopped at every tile because it like collided with the next tile. And what you need to do to avoid that is to update X separately and Y separately. So you actually have to kind of update the physics by X first, then checks for collisions by X, and resolve by X. And the same for Y. So depending on which axis you're using, that's the thing that actually gets resolved. So each dimension gets resolved at a time. So I'm gonna make an axis that is gonna be an enum. Whoops, it's gonna be like X or Y. Okay. And we are going to say let's do, well, I'm just thinking about what we need here. I'm just going to start with resolve collisions. So we're just going to do resolve collisions first, okay? And this will be a grid. I'm not sure if we need we probably don't need to mutate it, but I'm going to get a pointer anyway. And we need some way to get all the things that we need to check for. So I'm going to also bring in game here. Which has like game has like everything you need to get all the different entities and stuff like that. Okay. And I guess that's it. Then at the end we could return some kind of event. Like let's say something happened here. Like we had a collision event between the pac-man and let's say, you know, a pellet or whatever those are called. The small things that he eats, or he or she eats. I guess it's a he, since there's a Miss Pac-Man. I don't know. It's called Pac-Man, so it's a he. Whatever, it's they. Okay. Anyway, never mind. and then or if a ghost hits the thing, okay, so, or the cherry or whatever, the power up. So that's like the three different, like that's like the three different events that we actually can have in the game. So I'm just gonna say that we get a collision event, because basically only one of those is going to happen every frame, I think. So essentially we just call this should give us one event, right? So this is just going to be, well, it can be a union enum actually, because we can store some data as well. So you're going to quicksand. Yeah, I know. Okay, so this is going to be, I would rather avoid those things. Anyway, we're not here to talk about that. We're here to talk about programming, making games. Okay, so collision event. Yes, so either your collision with a pallet, that can be, and we give us an entity, which is from ECS, and or we can collide with a ghost, or a wall, I guess, but we don't really care about that. We might, yeah. And then there's also the wraparound, but that's not here nor there. Okay. So, well, it's there. It's not here, but it's somewhere else. Okay, but it's not there yet. Okay, so we have resolve collisions. Now we also want to put in axis, because we only, and let's do comp time here, just because we can. So we have an axis that is going to determine which of X and Y, or Y, we're going to check first. Okay. Which means essentially before this, the physics system updated the X-axis, and then we're checking for collisions, and then it's updating the Y-axis, checking for collisions again, and so on. So resolving collisions. So this should detect collisions and also resolve at the same time, is the idea. Okay. So how do we do that? Well, we are probably only gonna check Pac-Man going around. I mean, I guess the original probably did something very clever. Maybe it kept track of which row or column or something you were in, because you can go both. You can go both like up or down, left or right. And so it's like if you're in one cell, if you're in like one of the cells in the corners or in the like an intersection, you can choose to go left, right, or up or down depending on which way is open or closed. Maybe each cell has open intersections that you can go. That could also be a one way, and that could be another way to actually make this. You can still have the grid, but you kind of define each cell has like this road is open to the left and right, or down or up, or it's, you know, it's closed. So essentially, instead of checking if it's solid, we're gonna say like up is so basically if it's, well, you can make like is open or something. I don't know what to call this. So open or closed. So up is open, left is open, whatever, you know, or down. Sorry for using the terminology here. So everything is open. So then we won't have this is solid. So instead of checking for collisions, really, we're checking like, okay, if you try to move left, but left is closed, and you're like at the edge or whatever, then you would, you know, be stopped there. Yeah, it's a little bit complicated. I think I'm gonna go with this because this is more, I guess this is, I guess, more like open-ended here, this way, because now it's kind of more universal, but it's not gonna be exactly, you know, it's not gonna be exactly pixel perfect like Pac-Man, where you're at the corner, you press up, even if you're not fully in the center of the, or if you're at the intersection and you press and you're like slightly off the wall and you go into the open, you turn into the, you basically make a turn. You don't have to be exactly at the center to be able to move into the new corridor, because Pac-Man would kind of slide into the corridor a little bit. I'm not exactly sure how we're gonna manage to do that here, but I guess we'll figure it out. I was just thinking like maybe if I think like how they did it, maybe, you know, we can make an easier way to do it, but I'm not sure if it's going to be easier at all. All right, need to take a sip here. Okay. Okay, so let's see. So yeah, we should be going through all of the things that has a body, and I'm also gonna get the renderables, because this is kind of how we get the hitbox of something. Actually yes, okay, and then we'll go through those. All right, so here we're going through all of the things that has body and renderable. So basically the physics body and the thing to get the hitbox. So let's get the hitbox here. I believe I had a hitbox function. No, I don't. So let's make one. Hitbox. And we give a context, which is an empty context, which gives us a rectangle, which is the hitbox. And it's gonna be like local hitbox, or is it gonna be world hitbox? I don't know. Let's get the body. And renderable. No, it's gonna be world coordinates, yeah. So we'll get the hitbox. It's gonna be renderable dot. No, this is the size, and then position is body position. Okay, actually, this is like rotation, but we don't really have rotation in this game, so it doesn't make sense. And then size, position, and then yeah, and then we just return position X, position Y, size X, size Y. However, the position, no, this is correct. Yeah, that's it. Okay, we actually only need the context, so I'm just gonna do this. Actually, it's easier maybe if we do provide the game, so I'm just gonna do that, because now we can just say game.hitbox. Okay, so There we go. There's the hitbox. Now, we want to check for collisions from this hitbox onto the grid. So first we want to check, okay, which area of the grid do we need to check? Because the hitbox could potentially cover more than, you know, whatever area we need. So essentially, it's going to be what would that be? That would be, so first we have the grid position. It's gonna be like hitbox X, hitbox Y. We are going to divide this or scale by, wait, divide is a vector. Yeah, we scale it by 1 over whatever the cell size. No, yes. The cell size, which I guess we can get from the maze. Maze cell size. And yeah, so that's going to be the grid position where we need. So this is going to be the first, because this is the top left. This is going to be the first like cell of the grid that we need to check. But then we also need to check. We also need to like. This is the min position, and then we have the max. So min is like top left, max is bottom right. And we actually just say hitbox. Let's get like hitbox min is X, hitbox Y. And then we're gonna do hitbox. Well, we could either do like hitbox max, scale that as well, or we could just add. No, yeah, let's just do max. It's gonna be min plus the size. Well, width. Okay, it's gonna be init, width, and size, height. I really wish the rectangle struct in raylib was just comprised, instead of having like x, y, width, height, it was comprised of position and size, because then they would be vectors and would be much easier to work with. I really wish they could make that change. I'm not sure if that's on the roadmap or if anyone think it's a good idea. Maybe that discussion has already been done or something. I don't know. And this would just be hitbox max. Yeah, this is a comp time expression. I wish, I think it, I hope it doesn't truncate this, because this is an integer. I hope it converts it to a float and then like does it, but whatever. Okay, so we have the min grid pos and the max grid position. So these will correspond. This will also, hang on. This is scaled. We're also going to have to floor. God damn it. Yeah, I'm gonna floor this. And this, because we can't floor it, no. And then this one we're gonna ceiling, so that will cover like all that will cover all of those cells there. All right, Robotic Head. Thank you for the raid. See ya. Okay, so then, so now we have the min grid position, max grid position. Now we can check like for all the cells that we collide with. This will be like if pac-man is like, well, pac-man is actually 16 by 16. So potentially it could actually reach to collide with like, if it's like in the center of a wall, which it probably never will be, but then we could potentially reach like 9 different wall segments at the same time. But probably most likely it's going to be more like 3 maximum that we're going to collide with. If we try to go down, let's say, against a wall. Oh, 1 second here. All right, sorry about that. Let's see. Okay, let's continue here. Okay, so now if we like find any, so we can loop through all of these things. So we can loop through from position X to max. We probably, now these are floats, but sometimes that works. I'm not sure if it does work now, but yeah, maybe. They should be, you know, integers though. I mean, they're floats, but they shouldn't have any decimals. we're floored and sealed them. Sealing and floored them. Okay. So now we should have our cell. It's going to be self data, and then this is going to be x plus y times width. So this is our cell. And now we have the cell information. We can check if the cell is solid. If it's not solid, we don't care about it. Okay, but if it is solid, now we can essentially resolve the collision there. So we probably want to, yeah, we just resolve collision for one. I think it's enough if we resolve it for one cell. We don't need to check like all the different cells that we collide with, I think, because we're gonna do one X pass and then one Y pass. So we only want to check if we collide on the X axis right now. So we're gonna check now. We're gonna get the cell hitbox is going to be this. Well, we could let's do it like this. So if the cell position is going to be x and y scaled by the cell size. Okay, so that's the position in pixels for the cell. And then we also have the cell size. We already have the size there. So the hitbox is essentially cell position. That's the min, and then the max is cell position plus cell size. But we only need to check the x-axis now. So to check if we collide on the x-axis, we will say that, okay, so either we have hitbox min x is going to be less than cell position x. No, the maximum plus cell size. Yeah. So that means that the left kind of border of our hitbox that we check here are gonna be less than x plus cell size. That's the right side of the cell, which means then it means we've passed into the cell. So then we will say that that's a collision. So then we can have like or hitbox. So that's one side. Then we need to check the right side as well. Actually, no, this is wrong. We should check both, because otherwise, yeah, you need to check like y as well, because otherwise we don't. Yeah, I'm stupid. Let's actually just make the hitbox here. Hitbox is gonna be so rectangle init. Actually, then we can just do this: y plus cell size. The width is just gonna be cell size. And height is cell size. This, no, it's not, it's times the cell size, not plus. Okay, so there we go. Now we have the cell hitbox. And we can use, so we have both the hitbox and the cell hitbox. So we can use raylib check collisions rec, I think it's called, or rex. And so we have the hitbox and the cell hitbox. So if those collide, so this will do the same thing I was trying to do, except it will check both dimensions x and y. I'm just using this for convenience because raylib has this built-in function here for it. But it's a really simple check, really. It's like checking two rectangles if they are overlapping, essentially. Okay, so if they are colliding, we want to check, okay, what is the, so remember, it's not enough to check collision here. I also want to resolve the collision, which means I need to push the original, the body over so that we don't collide anymore. So I'm going to calculate the difference between X here. So it's going to be the difference between, so basically the depth of the collision. And now it's going to be, yeah, so I need to actually make sure I get the correct thing here. So we need to actually check if hitbox X is less than cell hitbox X plus cell hitbox width. That means we are approaching from the left side. No, wait. Or we can be very far to the left, actually. So this is one of the differences. D1. I'm gonna call this distance left because it's like to the left of our hitbox. How much is the distance to the right side of their hitbox? And then distance right, how far is it from our right side, which is hitbox X plus hitbox width. And that should be, actually this should be negative here because we're trying to calculate the distance. So if X is less, then this will be negative. If it's positive, then we don't collide. Then we're not actually colliding, I think. Wait, no, we can still collide. Yeah. Yeah, we can still collide on the right side. So the right side, we take this plus this and then minus the right side. So hang on. So left side minus this. So if this is larger, it means that this will be negative. That's going to be collision there. But this can also be negative because we can be like contained inside the cell, essentially. So we need to check the right hand side as well, but here we don't need to add the width because this is the left side of their hitbox. This is the right side of our hitbox. So we take the right side minus their left side. If that's negative, that means the right side is passed. So that means collision on that side. Both can be negative though, but both can't be positive because we need the collision on one side because we have collision here. So we know that one of these should be negative. So one of them could be negative or both. Now, I need to import Raylib as well. Now, all right, we're not importing its file from somewhere else. But anyway, now we want to check which one is it largest or smallest now? If it's largest, we're gonna get the one that is further away. So left. So if we approach from the left, we go into the wall. The left hand side is passed. So that should be the shorter. Yeah. So we're gonna pick the one that's lesser. So if abs of the left is less than, I'm just gonna make sure here, because what if left is negative but right is positive? That just means we aren't inside the object yet. And that should still be more, yeah. So this should be okay. So if the left is smaller than right, it means that we collided on the left side of our hitbox. That means that we should correct body X to the right. And basically otherwise we correct it to the left. Yeah. So if the distance are equal, if you're exactly in the center essentially, then we just pick a direction that's gonna be to the left there. That's probably never gonna happen. Okay. And but this is only for this axis actually. So this is like so we're only checking X here just because axis, I mean, we don't know if it's X or Y, but we're gonna we could do something like this, axis equal to X, then we do this. We can also like generalize this to make it work with both axes without having to copy everything. I'm just gonna copy it right now to make this work here, but essentially I want to implement this here first though. 1 second here, someone at the door. Right, my time is up today, but I will just finish this here. So basically we can say body, wait, don't we have the body? Oh, we don't. Well, we can get the body here though. So get the body, it's gonna be context get body. Okay, so then position X is gonna be plus equals and then the distance is going to be the left here, although the distance is negative, so I guess it will be like we go back the distance here. Yeah, okay, and then this will be to the left, so this will be like right, same thing there. Okay, except this should be negative because we're going to the left. So that will do it for the x-axis. Then we're going to do the same thing for the y, and we're essentially just gonna replace x with y, but not hit not hit boy. Okay, there we go. Okay, so we are colliding now, and depending on which axis we're currently want to resolve, we are resolving first for the x and then for the y, or the other way around. I forget which one we should do. Maybe y first and then x. I don't know. We could try a different ones. And then, I mean, yeah, this could be called like, I mean, this would be y is actually then top and your bottom here. So there we go. And then you should be height instead as well. Okay. There we go. Cool. Hopefully this works. Okay, so now, I mean, there's a couple of things left as well. We need to populate the data and then call this function. But there's really not that much left for this to work. We just need to populate the data. It's going to be the, I guess, the hardest part, maybe. I mean, we just go through the maze, actually. It actually could be just comp time data, now that I think about it, because we could just go through the maze, check if all the tiles that are empty. Yeah, we don't even need this these fields here, really. We could actually just make this comp time. But that's gonna be it for this time. Maybe I'll continue because this is kind of an interesting project, I feel like. So maybe I'll continue with this next time because I feel like I really want to get to some actual like core gameplay. We don't even have the correct like movement or collision or anything. So yeah, we'll probably continue with this next time, but that's gonna be it for this time. So yeah, thank you very much for joining and watching and chatting with me. And I hope you have a nice day, and I'll see you later. See ya. Yeah, I'll see if I can send you off here to somewhere. Let's see. All right, this one should be fine. All right, have a good one.
Pas jouer avec, tu vois.
En fait, ça veut dire que si tu récupères une arme en plein milieu de mission, tu dois pouvoir revenir au hub pour l'améliorer sans devoir recommencer.